Hello dear students, welcome back to my YouTube channel. So hello sir, please class 11th का भी पढ़ाना start करिए. Yes, definitely beta. After completion of my 12th, no, within I guess in next month we will be completing whole 12th. Then we will start 11th. Don't worry about it. And also we will be covering full 11th before December of 2025. Okay. Hello beta, Vinay Kumar. Hello. Hassan, hello beta. Am I audible and visible to all of you? Am I audible and visible to all of you? Yes. Am I audible and visible? Am I? Yes. But why is it not showing for me? 1 second, I need to check it out for myself, no? I'm not getting any sort of 1 second. Yeah, now it shows here. 1 second, I need to correct my sort of thing, no? Because if I'm not getting this thing, so how am I supposed to get my voice, right? 1 second, beta. So I am audible. Okay. Yeah. My internet is somehow lower, no? I hope that in yesterday's class you were present, no? Yeah, Hasana was present, I guess, in yesterday's class. Vinay Kumar was present in yesterday's class, I guess, right? Sundarja, I don't remember the. Okay, it's from 11th. Okay. Okay. And I hope that if you were present in yesterday's class, that is good. If not, then do watch the yesterday's lecture. Because in yesterday's lecture, we discussed a brief introduction of capacitor, what capacitor is basically, and why is the need of capacitor, what is parallel plate capacitor, what is it is a capacitance, right? C, and what is the relation between C and charge and potential difference, right? So those things we discussed yesterday, and what is parallel combination of capacitor, what is series combination of capacitor, what is work done by your battery that gets stored in sort of potential energy delta U, 1 by 2 CV square, right? So these things we done in yesterday's class. Okay, and I have given you many homework numericals for yesterday class also. So these are yesterday's class homework numericals. I hope that you have done these things, right? If not, then you can just let me know, sir. We were not able to do these numericals, and I will show you. I need your answer for it, now. If you have done these numericals correctly, then I can move forward. If not, then I will show you how to do these numericals. Fast, beta. So you need to give me responses. Now I don't have any kind of superpower. I can read your mind from your name only, okay, or from your watching only. So I can consider that you have got the answers, right? I will just I will assume it, okay. Okay, I will assume it that you have got these answers. 1, 2, 3, three numericals. Okay, let us forward now. How many numericals we have done? These numericals. Okay. let us do a unique. Let's do a unique one now. Lecture number second. Lecture number second. Lecture number second. Okay. Asana, no sir means you want the solution of your homework numericals? You want a solution of homework numericals? Huh? How to solve first and second? That means you have got the third one, no? That means you have got a third one. Okay, you need to tell me, no? You need to tell me that sir, we are suffering, no? Look, to get these numericals done now, what you need to do, sir, I need to replace the capacitor by resistor so that I will get a viewpoint of it. How, sir? Look now. Suppose potential of this point is, let's suppose A. Same A is here. Yes, sir. Same A will be here. Same A will be here. Okay. Potential of this one is B. Same B will be here. Same B will be here. Same B will be here. By point potential method. The potential of this one is C, so this one is also C, this one is also C, and here you can see now this one is C, this one is C, this one is C, and this one is C. Look beta, this one is between A and C, between A and C, between A and C. So between A and C, how many capacitors we have? 3 capacitors. So between A and C, 1, 2, 3. So these are between A and C, right? This is point C, this point is A. Capacitance is C, C, C. Look now, between C and B, C and B, C and B. So between C and B, how many we have? So we have 3. We have how many? Sir, we have 3, right? B point, C, C, C. Look, these 3 are in what? Parallel. So their equivalent will be how much? 3C. These 3 are in how much? Parallel. So it will be 3C. I will make it like this now. 3C, 3C, 3C. Now 3C, 3C. Now these are in parallel. So these three C are what? In a series. So I will write 1 by C equivalent equal to 1 divided by 3C plus 1 divided by 3C. That came out to be 2 divided by 3C. That means C equivalent came out to be 3C by 2. Done? 3C by 2. Same case with this. Potential of this one is A. Same potential, this here will be A. Here will be A. Done? Potential here will be B. Here will be B. Here will be C, C, C. This one is between A and C, A and C. So I will make it like A and C between 2, no? Between A and C are 2. A, C. Then C and B is 1. C and B is 1. This C, C, then I will take here B. So between C and B there is 1. Okay, this one is point is C and B. If this is B point, no? This one is A and B. A and B. So A and B is this one. Look, that means these 2 are in parallel. So their equivalent will be how much? Sir, their equivalent will be 2C. Now 2C, this one is what? Parallel. So I will write 1 by C equivalent is 1 by 2C plus 1 by C. So I can write it is C plus 2C divided by 2C square. So C equivalent will be 2C square divided by 3C. It is 2 by 3C. 2 by 3C, right? Now 2 by 3C with this one is parallel. So I will write 2 by 3C plus C. It will be how much? 2C plus 3C divided by 3. That means 5C by 3. Look. Answer. Vedantu. But yes, it is possible only if your basics are clear. Okay. If your purely basics are clear, no? That means, sir, how to apply these things and what is the definitional part of it and what is the equational things, right? If you have the basic knowledge from 11, 12, not advanced level, if you have the basic knowledge, that means Sir, if we do the manipulation of mathematics, what will be there, right? If you have the formula thing, if you know each and everything regarding the IIT, okay, then you can just follow any course and you will be doing lot of in-depth study of any particular things, right? Then follow PYQs and do the hard work 15 hours a day, then definitely you will qualify. But if your basics are very clear, then it is possible. It is not like you don't have any knowledge about anything. Okay, that it is, I guess, very difficult, very difficult. This one is easy now. How, sir? Look, potential here is A, here is A. Potential B, no? So here will be B potential, here is B potential, B potential, B potential. No, this no work, no? No potential drop. A by B, both are in what? Parallel, so their equivalent will be 2C. Basics means that if I just ask you a simple part, that is beta, what is the equation of trajectory from your kinematics? Okay, you must know about the equation, no? This is basic. Okay, if I tell you beta, what is the value of let's suppose cos 5 degree, you must know it. Okay, if I tell you beta, what is a difference between different coordinate systems, cylindrical coordinate system, spherical coordinate system. Okay, so you must have that knowledge about what these things are related, na? And if yes, if you are very good with these things, then go on. I will give you a suggestion, then go on. Okay, if you have made your mind na, that you want to do the IIT, then start from today. Okay, just find any teacher, focus your studies, and just trust your teacher blindly. Buy any course, okay, and do the homework, DPPs, all those things. Then definitely you can do it. So now we are done with yesterday's numericals. So we are having lecture number 2nd. If we have the plates, look, you will find some numericals like this now. One plate, one plate, one plate with some thickness. These are some plates with thickness. This plate is connected. This plate is like this. Plate A, potential A and potential B. Okay. Then you need to get, if let us suppose you need to get C equivalent, or how to form capacitor from this. How to form capacitor? Look better. If suppose this is positive, suppose now this one is negative, that means this thing will be positive. This thing will be positive, right? This thing also will be positive. Why? Because we have given positive charge to A now, and we have given negative charge to B. We have given negative charge to B. Look, again, this is first capacitor, second capacitor. Two capacitors. Look, this capacitor, sir, this one A, B. This one A, B. So can I write now like, look, one capacitor AB, one more capacitor AB. Why, sir? Look, this side is connected to A, this side connected to B. This one to A, this one to B. If this is C, this is C. What will be C equivalent now? Sir, 2C. Or C net, what will be? Sir, 2C. C, what is C? A epsilon naught by D. This is how you can do it. And you will find lot numericals based on this one from each and every module and DPPs of your institution. Next numerical from same topic. 1, 1, A, B. Sir, how to do it now? Simple. Sir, this will be positive. This will be positive. Suppose this is positive. So this one will be also positive, no? Suppose. This one will be negative. This one also negative. This one negative. This one negative. Else, second type. Potential of this one is A. This one is B. This one is B. This one is A. Look, BB, no effect. So this one is 1, AB and AB. Both are in what? Parallel. So you write 1 parallel, second parallel. CC. What is C equivalent now? 2C. 2A epsilon naught by D. If you have any confusion, beta, you can just let me know here, right? There is only one thing now. Look. One second, beta. Give me 1 second. Done? Am I visible now? 1 second. There was some spammer, no? So I need to just kick those people out. Jyoti, hello, beta. Sundarja, beta, you need to just wait for a couple of things, right? I need to firstly complete my 12th because this is my promise to my students. Then we will start 11th. Don't worry. We will start 11th. And before December, we will complete 11th also. Don't worry about it. But first, for my priority list, I need to complete 12th firstly. Now, one more numerical. One more numerical. One second. A, B. Sir, how to deal with these types of numericals? No issue. So this one will be A, na? So I will write, sir, this is A. This one is B. Suppose this one is X. So this one will be X. This one is X, right? This one is between A and X, A and B, A and X. Done? That means AX, A, BX2. So we have extreme point, we have A, extreme point, we have B. Now here we have X, right? AX between 1, we have AX. Okay. AX, then we have BX. Then we have BX one more. Then we have AX, BX, then we have AB. Then we have AB. Okay. If this is C, this is C, this is C. So C into C, that is C by 2. Okay. So now I will write it like this one. Look now. This one is C by 2, this one is C. So what is C equivalent now? C by 2 plus C, that will be 3C by 2. This is my answer. If you have any doubts, you can let me know. Because you know now, in capacitor cases are opposite to that of resistor cases. Okay? Done? Easy? Okay. So I guess you are very good with these topics now. You have a very good knowledge about how to do these numericals. Now let us start dielectric. Let us start now. Dielectric, one of the important topics and most interesting one. It is also important one. Okay, just mark it as important one. Dielectric. Done better. Dielectric. So what is dielectric? Don't think much about it. So you will set only sir dielectrics are the mediums which are insulators. Okay, shortly. What are dielectric? These things? These are insulator things. Not more than that. Done? And we know now the property of insulators. We know these things. No? I think I don't need to repeat the properties of insulators. Why? Because we have done the insulators in our electrostatic. We done insulators from current electricity now. This is third time we are repeating the insulator topic, right? Okay. So now, just like insulator or dielectric, we have two types of dielectric, right? Two types. Two types, right, beta? Okay. Two types. One type is known as polar dielectric. Polar dielectric. One dielectric is known as non-polar dielectric. Non-polar dielectric. If we talk about the example is polar dielectric, meaning that is suppose HCl molecule. That is suppose H2O. If we talk about non-polar, these are let us suppose H2 gas, N2, CO2, etc. Sir, what is the basic difference between polar and non-polar? Polar dielectrics are those in which you can write each atom has its permanent dipole moment. Dipole moment. Okay, and this was asked in your NEET. This particular side is NEET PYQ. This thing was asked. If we talk about non-polar, each atom has zero dipole moment. And you also know that what is dipole moment from electrostatic chapter. I don't need to repeat it now. That's why I'm telling you these chapters are interrelated. So polar molecule looks like this. Look now. Positive side, negative side. But non-polar looks like this. Positive and negative coincide. Okay. So you will write here a reason for it. Reason for it. So what you can write? You write here due to symmetry. Due to symmetry. Center of positive charge and negative charge coincide. Center of positive charge and center of negative charge coincide. Okay. So this type is known as what? Non-polar. So dielectric, basically these are insulator materials. We have two types, polar, non-polar. Polar means in which each particle is having its dipole moment, Q into L, right? Non-polar means in which each particle is having zero dipole moment. Now, one second. If we have a bigger image of it, this is our material, polar dielectric. This one is our non-polar. We are talking about it, no? So these are some particles. Look, I'm taking time so that I can make it very perfectly. Okay. Look now. Suppose negative, positive, negative, positive, negative, positive, negative, positive, negative, positive, right? Each particle is having its dipole moment, no? Each particle is having its own dipole moment. We know it very well. Okay. But what is net? So you will write here for this one, sir, net dipole moment. Net dipole moment. Net dipole moment is 0. Why? Because due to its random position or orientation. Okay. So net dipole moment of a polar dielectric is also 0. 0, shunya. Now if we talk about non-polar. So non-polar looks like this now. Non-polar looks like this. Look. It coincide. Now look. Coincide. So I guess if you add now 0 plus 0 plus 0 plus 0 plus 0, you will get 0 always, no? So you will also write here net dipole moment is 0. Reason being because each and every particle is having its own dipole moment 0, no? Okay, you can take a screenshot of it, no, if you like. Dielectric, polar, non-polar. Polar atom is having it as a dipole moment, but net is 0. Non-polar atom is having 0, and also the net is also 0. Now, if we place these dielectric things, whether polar or non-polar, we will place polar or non-polar in external electric field. What will happen now? So you will write here. What you will write? When dielectric is placed, in external electric field. In external electric field. So what does it mean? Suppose we have any dielectric. Okay. So here I will write now. Let's suppose this one. We are taking example of this one or this one. There is no issue. What will happen now? If we are placing electric field, I guess this is my electric field. This arrow represents our electric field. I will write E naught. This is external electric field. And you know one thing, that is whenever we are placing any dipole in external electric field, my dipole gets aligned in the direction of applied external electric field. How, sir? So we know that what happens now, it will go align, it will align. Each and every dipole will align. Why? Because these dipoles will feel a force or a torque. How, sir? Look, beta. This one is negative, positive, negative, positive, negative, positive. Why? Because electric field came out from positive. So positive will attract in negative side. That's why negative will be in the opposite direction of my electric field, and positive will go away from the direction of my electric field. And this is my electric field. It is scenario of both cases, no? It is both cases, whether you are dealing with polar or non-polar. That means if we are dealing with polar or non-polar, both will behave like the same. Both will behave like the same. And this particular thing is known as dielectric slab. dielectric slab, right? Slab means a cuboidal thing. Done? Look now, beta. Positive, negative, they will create their own internal electric field. I will write E internal, or more accurately, it is E induced. It is induced electric field. That means this electric field gets created due to the effect of external electric field. This electric field gets created due to the presence of what? Due to the presence of external electric field. So how many field we have now? So we have two field now. First one is external electric field, due to which dipoles align themselves in the direction of the external electric field, and due to which internal electric field or induced electric field gets generated. Okay, sir. Now, if somebody will ask you what is E net, look now, what is E net now? E net. E net. E net means what is the net effect of electric field inside. You were right, sir. Outside is E naught minus E induced. Minus E induced. Why, sir? Because look here. Okay, look here. E naught is going in this way and E induced is going in this way. What is E net? It is E naught minus E induced. E naught minus E induced. One more thing that you have learned from the Coulomb's law. That is dielectric constant epsilon r. It is also equals to K, which is equals to permittivity in medium divided by permittivity in free space. This thing you need to remember from the Coulomb's law. Done, beta? Okay. Praveen, beta, first of all, I need to deal with my 12s now. I can understand your things now. I need to just deal with 12 firstly. So in next month, most probably I will complete my 12. Then we will start 11th. No issue. Okay, now. So now we have the idea regarding dielectric things, what dielectric is all about. Okay, what dielectric is all about. Now, if we are placing dielectric in external electric field, what will happen to it? We know about it, right? Now look now. Suppose now. Think about it now. If we have a capacitor now, this one is my capacitor. I know that inside the capacitor we have positive charge now to one side. It is what? Positive side. One side we have negative charge. What will happen now? Electric field gets created between it. Now, why? Because positive negatives, there will be electric field. It is what? Electric field. Done? A side or B side? No issue. So inside what we have vacuum. Somebody will ask you, write electric field. I guess electric field E naught is equals to sigma divided by epsilon naught, and we had done the derivation of this thing also in our electrostatic chapter. Now, if we introduce a dielectric in between, okay, point A, point B. Look now, I will introduce a dielectric. Okay, still this one is positive, this one is negative. We know it. Yes, sir. I know that there will be electric field like this. It is E naught. And we got now there will be E induced inside also. E induced. Done? E induced. Now we need to talk about this E induced now. Look, we need to talk about this E induced. Look now. So I guess what is E net from this equation? Sir, E net is equals to, is it E naught minus E induced? Okay. E naught is simply sigma divided by K times epsilon naught, equals to E naught is sigma divided by epsilon naught minus it is sigma induced. It gets induced divided by epsilon naught. Epsilon naught cancel out. So sigma induced is equals to sigma minus sigma divided by k. It is equals to sigma 1 minus 1 by k. So sigma induced is q induced. It is q induced divided by a is equals to q divided by a 1 minus 1 by k. Done. A cancel out. Therefore, my charge will get is induced here. It is equals to q 1 minus 1 by k. This equation, I guess we had done this equation before as well in our types or methods of charging topic. When we were dealing with methods of charging topic, so there we had discussed about this formula. Now this is proof how we get this formula. If we are dealing with metal, okay, if we are dealing with metal, look, if we are having metal, for metal, k tends to infinite. So this equation I will write as a q induced is equals to q divided by 1 minus 1 by infinite. 1 by infinite is 0. So I will write q induced equals to q only. In case of metal only. In case of metal only. Let us do some numericals. Look better. We will be doing some numericals. Capacitors, right? A point, B point. This side positive. This side negative. Inside vacuum. Inside vacuum. Now make a graph of distance. Make a graph at distance and your electric field E. Do you know what is the electric field value inside? Sir, it is E naught and it is constant, which is sigma by epsilon naught. It is constant, na? That means here, every point, na, it will be same. That means it is always constant. Value is how much? It is sigma by epsilon naught. Now, let us introduce a dielectric now. Let us introduce a dielectric now. Okay. Positive, negative. This one is dielectric. Make a graph of dielectric now. Make a graph of it. Distance E. Look, if we are dealing with it now from, let us suppose, from this point to this point, it is vacuum. So the dielectric is how much? Sigma by epsilon naught, it is constant. That means up to certain point it is constant. Now when my electric field goes inside, it gets decreased. It gets decreased. So I will write, sir, it will be somehow here. Now this one is also vacuum now, same, so it will go increase. So this is my graph. This one is my graph. Okay, you can see better. You can see here now, this one is my graph, which shows that this is maximum in vacuum, maximum in vacuum. Now it is in some dielectric constant. This is how you need to think about these graphs. Let us do couple of numericals based on this graph only. Okay, one more numerical. Suppose we have a capacitor like this. Positive, negative. inside we have a dielectric. Inside we have a dielectric here, right? Look. One more dielectric here. Done. This is K1. K1, this is K2. And K1 is more than K2. Make a graph of it. Distance and electric field E. One thing that we know that, sir, in this particular portion, in this one and in this one, these are vacuum, and in vacuum my electric field is E naught, which is sigma by epsilon naught, and it is maximum. So in first phase, then in third phase, 1 1 2 3 4 1 2 3 3 is also this one, no? 3 4, so I need to write here also this one. Okay, now K1 is more than K2. What does it mean? So what is E? Sir, E is equal to sigma by K times epsilon naught. Done. So can I write now E is inversely proportional to K? If K1 is more than K2, then E1 is less than E2. E2 is more, then E2 is more, E1 is less. Okay, this is how this graph will be there, no? This particular side shade is air or vacuum, air or vacuum, air or vacuum. This is first one is K1, this one is K2. So you will get these numericals in your chapter, no? So you need to tackle with these things now. Okay, you need to be so clever now that you need to deal with these things. Okay, one more now. If we are placing a the conductor, if we are placing a conductor, look now. If we are placing a conductor, look. Okay, this is what conductor. Conductor, and you know that E in conductor, E inside is 0 always. Positive, negative. Make a graph of it. Make a graph of it. E and distance. E and distance. Done. So here it is E, that is maximum here E. Inside is 0. Inside is 0. So it is 0. Then here it is E. So the graph looks like this. This is my graph. This one is from my conductor or my metal. Or a metal. Okay. Done now. And why? What is the reason, sir? Because E is equals to E naught divided by K, and K for metal is infinite, so I will write E equals to E naught divided by infinite. Something by infinite is 0, so E equals to 0 inside a conductor. A reason. This one is my reason. Done. Okay. We have a lot more time now. Look now. Suppose we have a capacitor. Capacitor. Positive, negative. Area is A. This distance is D. Distance is Z. What is C? Is it A epsilon naught divided by D? We know it. Or it is V vacuum. No issue. I guess we had the derivation on it, no? We did the derivational part also, right? Clear? Okay, sir. Now let us suppose we are introducing a dielectric in between. Let us suppose we are introducing what, sir? We know this part is positive. We know it very well. This one is negative. We know it. Let us put a dielectric here. No? Dielectric is in between with dielectric constant K. Okay. D is distance. Area is A. This is A and B. So what is C? Sir, C is equal to A epsilon by D, not epsilon naught. Okay, A. What is epsilon? Sir, I guess epsilon is equal to, do you know it is K times epsilon naught by D? Okay. These terms belong to C vacuum. So therefore, I will write C if we are having a medium equals to C vacuum into K. So by this equation, we conclude that whenever we are introducing a dielectric, one second, beta. Hello. One second, what happens to it? One second, beta. Hello, hello. Yeah, I'm audible. Okay, so whenever we are introducing a dielectric, capacitance increases. Capacitance increases. And here is a proof. Here is a proof. That means whenever we are introducing any dielectric in between the plates of parallel plate capacitor, it is dielectric increase. It is dielectric increase. Okay. Now look, now it is fully. That means this dielectric is completely filled. So I will write here. So if it is completely filled, it is completely filled. So we got this equation. Now if it is partially filled, then which equation I need to use here? If it is partially filled, we can do one more thing. Now case number third, let us suppose. Positive, negative. Hole is D, but thickness of this one is T only. Electric field will be available here E naught. Here is E naught, but internal is how much? E induced also. E induced, this is derivational part. So we are dealing with derivation of it. Okay. This is dielectric slab. Dielectric slab. Now what we can do? Sir, what will be V? What is V now? What is V? I guess V equals to E into D. Okay. I guess we have 2E. Here is 1E. Here is 1E. So there will be 2V. So V equals to E naught. E naught is present between this gap and this gap only. That means D minus T. E naught is present between D minus T only. Plus this E. This E is present in T only. In T only. So V equals to E naught D minus T. What is E? I guess I can write E K times E naught times T. I can write like it, no? No, sir, it is wrong. Why? Because K is E divided by E naught. It is right. No, that is epsilon. It is E, na? It is E. So it is not like it. So E will be equals to E naught by K. So I can write here V equals to, I will take here, it is not here. It is divided by K. So I will take E naught common. So E naught common. So what we have now? We have D minus T. Then we have plus T by K. Okay. So what is V now? V now, sir, Q equals to CV. So V is Q by C. So I will write here that it is Q by C. What is E naught? It is sigma by epsilon naught, and sigma is Q divided by A epsilon naught. I can write Q divided by A epsilon naught. D minus T plus T by K. Q cancel out, therefore my capacitance came out to be A epsilon naught whole divided by D minus T plus T by K. So this is my equation that I need to use. Think about it. So when you are introducing, whenever you are introducing what? Whenever you are introducing what, beta? Capacitor. Sorry, whenever you are introducing dielectric in between the capacitor. So the capacitance of that capacitor will be equal to A epsilon naught D minus T plus T by K. In case of metal or conductor, K tends to infinite. So therefore, C equals to A epsilon naught divided by D minus T plus T by infinite. This will be 0. So I will write A epsilon naught divided by D minus T. One more thing I can do it. So C equals to, it is medium, no? Equals to A epsilon naught. I will take D common. It will become 1 minus T by D. This thing is C naught, or C, it is C medium equals to C in air or vacuum divided by 1 minus T by D. Okay, we can do like this, no? This one is proof. This one is what? A proof for these things. Let us do some numericals now. We have plates. Plate, this is A point, B point, or point X, point Y. Left side we have one dielectric, which is dielectric constant is K1. This one is K1, this one is K2. This one is how much? A by 2. So this one will be A by 2 because whole area is A now. This distance is D. So what will we look here? What will be C1? Sir, it is A, K times A epsilon naught by D. Look, what is C now? It is K, A epsilon naught by D. So C1, it is K is K1, A is A by 2, epsilon naught divided by D. So I can write it K1, A epsilon naught by 2D. For this one, it is C2, that is K2, A epsilon naught divided by 2D. Look, potential of the whole slide is X. Potential of the whole slide is Y. Okay. So I can write 1 here. 1 is this one. 1 is this one. Look at X, Y. Potential of this side is X. X. Potential of this one is Y. Y. Potential of this one is X. X. This one is Y. Y. Capacitance is C1, C2. Both are in series, so C equivalent will be equal to C1 plus C2. Okay, what is C1? It is K1 A epsilon naught divided by 2D plus K2 A epsilon naught divided by 2D. So I will take common A epsilon naught by 2D common. It will be K1 plus K2. It is K1 plus K2. Done? Easy, na? Okay, one more type. If we have something like this. Now look. Y, X. D by 2 area is A only. In this one, we have K1. In this one, we have K2. This plate potential is X. This plate potential is Y. This plate potential is, let us put M. How to write it now? Look, one plate potential is X. This plate potential is Y. Now, this plate potential is M. This plate potential is Y. Y, X, M. What is potential of this one? C1. C is A, K, it is K1, A. A is same. Epsilon naught by D. D is D by 2. C2. So C2 is K2, A epsilon naught divided by D by 2. So it is C1, C2. Both are in series. So C equivalent will be C1 into C2 divided by C1 plus C2. Place these values. So what is C1? It will be 2 times K1A epsilon naught by D. Okay, look it up. Then multiplied by 2 times K2A epsilon naught divided by D whole divided by 2K1A epsilon naught divided by D plus 2K2A epsilon naught divided by D. Look beta. 1, 2, 1, 2 cancel out. D, 2 cancel out. A cancel out. Epsilon naught, epsilon naught, epsilon naught cancel out. What do we have now? So I guess D is also cancel out now. It's D square now. It will my Jasif Rachui. Now 2 we have 2 now. K1, K2 and A also now. So I can write 2A epsilon naught then D. We have here K1 into K2 divided by K1 plus K2. This is my answer. This one is my answer. Okay. So you need to solve like this. Done? Done now? Okay. So I guess we have done maximum portion of it. Okay. Now, okay, one more numerical that I want to give you, and that will be a crucial one. Okay. So this one we will discuss now. It is crucial one now. Very important crucial one also. That is, look. Okay. Find the answer. This one is your homework. So tomorrow we will discuss this one firstly, then we will start. Tomorrow, no, Monday, Monday where we will be discussing this numerical. Okay. So we are done with today's class. So we are going to start lecture number third now. So we will be starting lecture number third in Monday. So how many lectures we need now? I guess we need Monday, Tuesday, Wednesday. In these 3 days we will complete capacitor. Thursday we will start magnetism. Okay. So Monday until Wednesday we are supposed to complete the capacitor part. Then from Thursday we will be starting magnetism, or in the week or in 10 days we will complete magnetism also. Okay. Thank you, Beta. Thank you very much. Bye. Good night. Jaldi samko sir. So I guess we are done with today's class. Thank you, Beta. Good night. Bye.